So thank you so much for being here. And before I pass the mic over to Kate and to Carl, I don't know what that was. So one of the things that we're very lucky is that we get. Not only do we have speakers that come up from all over the world, but we also have DJs come from all over the world, and literally. And the next two speakers that we have are no different. And because I know that Kate is from New Zealand, right? You're from New Zealand? Yep. You know, the home of the All Blacks. Yeah. Home of the All Blacks. And so, without much ado, I don't think the next two need too much introduction. And because you've been to Black Hat, you've spoken at Black Hat and DEF CON in the past. And so, without much ado, it is my pleasure to introduce to you SecValve and Virus, Kate Pearce and Carl Vincent.
I already got one. Hey, so I have sort of busted up my voice. That's what happens from yelling at, well, things.
Blame Black Hat.
Yeah, blame Black Hat. Okay, so I'll try overpowering the voice thing, and I won't be able to talk for the next week, but I think I can make this work. Okay, so this is our session. HTTP term and QUIC, and I really shouldn't do that because I'm not going to talk by the end of this. Okay, I'm going to slow back down. Teaching good protocols to do bad things. So, as previously introduced, Kate, SecValve on Twitter, yell at me, people do. Security consultant at Cisco, breaking stuff, telling people, do it right. Research, which sort of led to this. Distinguishing features, loud, yellow, or maybe that's just a loud yellow. I'm also never going to get a better photo than that one. Ever.
So jelly.
Go to KiwiCon. Speak at KiwiCon. Get a photo like that. And then be like, okay, I'm done. That's just so amazing. All right, Carl.
I'm not important.
Yeah.
I break things. Hopefully I scare you.
Yeah.
DEF CON's about
scary.
what you say, not who you are, so screw this slide.
He's pretty scary. Just
It's left over from Black Hat. Just never mind that slide.
if you piss him off, just don't let him know. All right, so starting with a very uninteresting looking video of me just like getting a VM, and I'm going to start browsing some stuff. And let's not, come on, play, damn you. Play.
Something demo gods.
Something video gods. Come on.
It's kind of funny.
Worked fine the other day.
Right.
Play. Woo!
Yay.
Woo! I can talk like that all the time, but let's not do that. All right, so we decided to browse some Google News, which has... look, this was the New Zealand Google News that day. It's not my fault. I mean... okay. So, yeah, that one. Again, this was news. This was not me. This was the universe speaking to me. And so I decided, I got bored with that, go to YouTube, and I started looking for something to watch. And then, being the clickbait victim that I am, I decided, oh, Pokemon Go in 9 minutes. Let's have a look at that. Getting bored with this dude walking down the street. No one wants to see a dude. I want to see Pokemon, damn it. So I look up where I was going to be speaking in a couple of weeks down at the Mandalay. Wellington's where I'm from. Mandalay Bay, yeah. The hotel down the road. Stuff. There is a reason for all this. Right now, I'm just randomly browsing. Yeah, I'm randomly browsing. But there is a point. Mandalay, oh, yep, cool. How do I get there? Feel free to jump in, Carl. Say something.
Yeah, notice all of these services are all Google services that will become relevant extremely in a few seconds.
Yeah, I don't know why I was trying to get there from Spain.
A few more seconds. But yeah, the important thing to remember about the video until it goes away is that all the URLs that were visited are all public and are all running on Google's like native host cloud. So it's all the same web server.
Yeah, and this is an unmodified Chrome on an unmodified Windows. There's nothing fancy except, oh shit, TCP's blocked.
Like all of it.
Like, completely.
So why does everything work?
Yeah, like, what? How does it work with TCP blocked? Well, you'll probably find your browser's already doing this, but we'll get to that in a moment. Do you get the code working, Carl?
Maybe.
He's sitting there coding a demo as we stand here.
I know, right?
I mean, how hardcore. okay, so TCP was blocked. What the hell? I look at the PCAP, and there's this QUIC thing. What? And it's got a whole lot of headers and crypto stuff, and I have no idea what that is, but we'll get to that later. And I've got some other stuff. Going to Facebook. Okay, so the wire, so it's obviously encrypted. Look at the SSL. Yeah, that doesn't help. Then Wireshark does this decompressed header, whatever that is, and electric breakfast. Yeah, I looked up, and there's like a toaster collection thing on Facebook. I found that kind of amusing, and that was what I used for the example. I don't know why. But they have some really bling toasters. All right, so again, doesn't make much sense. It's a new protocol. It's already live on all of these things. So let's talk about some, wait. Let's talk about some things that are already here. Some transport protocols that are already making the world explode. You know, everything's getting bigger, faster, more connections, more different places, moving around. So if you want to get trending stats, go to the HTTP archive. They dump it all into Google BigQuery. You pull it up, you can query it, and you can put stuff like this, which shows you that, you know, your bytes and flow size are all going up exponentially over the last few years. The same with the number of domains, the number of requests, it's all going up. The reason this is all happening is because, you know, we need all these better capabilities to do things. But there's a few different ways you can do it. So HTTP 2 multiplexes within TCP. We'll get to that in a moment. And QUIC just says, you know, I don't need TCP. I'm doing this myself. And, well, yeah, they changed the way things work, quite substantially, actually. And the reason you care is because there's some familiar stuff, you know. You can't see through it. It's opaque. You don't know what's going on. That's what those teasers were. But there's also some new stuff. You know, some new fragmentation attacks, similar to multi-part TCP. And also, your network security right now probably has no idea what's going on. And yet, to be clear, personally, I like these protocols. They're more of a culture shock than a direct vulnerability or concern. I actually want them to succeed. Your stuff works a lot better and smoother when they're working. But no one's ready. And just because there's going to be always that one person, we're skipping ridiculous amounts of detail. Go and read the RFCs if you want detail, or ask us afterwards. Just don't be a dick. We're skipping so much. 2 protocols, 25, 30 minutes, a lot of detail. All right, so how do we get here? Why would these things come along? These things have come along. Multi-part TCP, presented on that a few years ago. Extended TCP to add multi-homing and mobility and link aggregation and all that. But that never really took off because if you're changing TCP, you need to have the OS involved. And if you've got hardware, yeah, good luck changing that. If you've got a router or a middle box in the way, it's going to screw with it as well. So, you're right.
The demo works.
Oh! Ooh.
Writing the demo in the talk.
Oh, yeah! Oh! All right. All right, who are we sacrificing to the demo god? This guy? Oh, I don't know. Can we take a rain check from the demo god?
No.
No? Oh, all right. Anyway, and you know, your middle boxes get in the way. And there's this whole chicken and egg deployment. We will do that. Don't worry, we'll show you that. There's this chicken and egg deployment thing where no one wants to support it until people are using it, and no one wants to use it until it's supported. And so nothing happens. And what I mean is, you want to TCP doesn't do things like high availability, link aggregation, or multi-homing. It's incapable of mesh networking, and it's really, really chatty. TCP is like, hi, do you want to talk? Yeah, let's talk. Great, let's do this encrypted. Sure, how do we do it encrypted? Great. And you've got so many round trips just to set up a conversation. And until you've got through your greeting, TCP is not going anywhere. It blocks until those retransmits are done. It blocks until that handshake's done. And that's really, really a problem. So multi-part TCP helps with those top 4. QUIC and H2 help with the bottom couple. And there's a lot of talk in various places of QUIC bringing in these capabilities of the top things into a user space network protocol. So, you know, if this is stuff you want TCP to do, and there are some reasons not to change TCP. As earlier, you know, it's handshake. You can't change that. It's kernel mode, it's outside user space, it blocks. You can't change that. But if you can't change TCP, what do? Well, SCTP. Do you know anything that uses it?
Yes.
What?
I can't tell you. It's a work thing.
Oh. So you can't tell me on stage?
Correct.
All right. I know things that use it, but by and large, especially in the consumer space, nothing uses it. It has the same problems as MPTCP, but even crazier, because MPTCP is TCP, HTTP is a completely different layer, and it just breaks everything. If you do it at the app layer, well, sure, that's what H2 and Speedy do. UDP doesn't do anything. Doesn't do anything at all, which is kind of the point. And that's why QUIC uses it. So to sum up these journeys, TCP attempted to change to multi-path TCP, and for various reasons, they decided QUIC was a better way to achieve some of those goals. And HTTP, to bring in some of these additions, they went to Speedy, and that was what led to HTTP version 2. Again, so what? Well, have you looked at how many security tools support either of those?
Hint.
Cloudflare supports them, but in terms of a security tool for your network, nothing much.
Cloudflare also can only see them on 2 ports and can't traverse QUIC. They don't actually support it. They just detect it, kind of.
Well, they do serve it. They serve it.
Yeah.
The H2 in particular is served on quite a lot of things. It's really unfortunate. And so, yeah, that prevalence. MPTCP came along really fast and then sort of choked. QUIC came along a lot faster because Google was pushing both client and server. H2 was just crazy. So QUIC is already probably 10 or 15% of your network traffic. Most YouTube traffic right now traverses QUIC. If you don't believe me, if you're not blocking UDP, go and look. Whenever I get someone to, they're like, whoa, what? And HTTP 2 has been even faster. So MPTCP, 50 million, it's in iOS, it's in macOS. A couple of ISPs have done some stuff, not too much. You bring on QUIC and you put Google in, and suddenly you've got a hell of a lot more. Probably understated a bit here. 1 billion, it's probably more like 1.5.
Something like that.
Something like that, yeah. You bring on H2 though. This is H2 over the last year for the Alexa top 1 million. 250,000 sites. So let's go with this line here. At least 15% of the top million Alexa sites are using this stuff. Over the last year. A year ago, no one was really using it. And that's crazy. When you bring in the client support, you're looking at 2-3 billion. That's an awful lot of things.
It's about 6% of the internet.
It's bigger than IPv6. And if you bring that up to, look at the top, call it 20. Facebook, Google, Twitter, Wikipedia, Yahoo, YouTube, Instagram. To be fair, there's a couple of companies overlapping, but most of the bigger sites are using these, and that's really quite surprising. Anyway, what are these things? How do they work? I'm going to have a cow for a moment and let my voice recover. Or I'll jump in if you...
Yeah, there's a lot of Black Hat references here that are all supposed to scare you into why this is relevant, but I'm not really feeling the need to go through these things at DEF CON.
Cool. All right.
There's a lot of common features, multiplex requests, which we'll get to in a minute, priority requests, which are frames and things. Okay, fun stuff. So, all right, the way that connections in general work for pretty much every protocol on the planet right now is like the internet is a series of tubes. Usually a TCP tube, but a tube. And what that actually looks like is more like this, because the tubes are full of packets. So the analogy that I use is pint glasses. Think of pint glasses with grains of sand, where each grain of sand is a different color. And usually, if you want to get 5 pint glasses from one bar to another, you have to have 5 different garden hoses to pour it down through. All right, well, multiplexing is when you have one garden hose and you pour all of those jars into one thing, and then you have a magic robot on the other side that splits everything into the same 5 glasses. So that means you create one connection, and then you give everything a magic ID in the middle, and it all comes out fine. So what this looks like in terms of differences is that, so with H1 on a typical TLS browser setup, you have a TCP connection, you negotiate TLS over that TCP connection, and then you send a plaintext request, you get a plaintext response. With H2, you have a single connection, and then there's a software level tracking of this magic number called streams, and you can kind of do whatever you want in each stream. You send a series of frames, and those frames tell it, give me bytes, or reset this stream, or...
A stream is analogous to an HTTP connection, basically.
You want to...
Nah, it's more Black Hat stuff, but sure, why not? HTTP, we know about that. H2, fun things. Binary framing, not human readable anymore. Multiplexed, it's no longer linear. Prioritize, which is particularly fun because you can request things, they can come through in a bizarre order. Compressed in a very stateful way, and server pushed, where the server will send you things you never asked for.
There be dragons there, by the way.
Oh, yeah. Some dragons coming for your face. Yeah. So H2, you got your transport layer, which has some number of frames, and each of those frames has a header and a payload, and there's a few of them, all right, cool. And if you start breaking that down a bit more, your frame with your header then has a payload, and that payload itself has various other headers and type fields, and it's nesting and nesting and nesting. This is a dragon's nest.
Yeah.
Yeah.
Yeah. All of these boxes are all binary frames, by the way. So yay, binary parsing.
And it gets deeper. We need to go deeper. And this is probably one of the slides that I probably should never have built in PowerPoint. You've got a transport layer with a stream. That stream is bidirectional and it has some frames sitting upon it, and those frames have all that other stuff. And there's a whole lot of frames on each direction, and then a whole lot of streams with frames. Like, whoa. Try and parse this manually, you're going to have a really bad time. Langsec, nightmare.
Yeah, Langsec nightmare. You should get to the quick stuff.
Get to the quick stuff, all right. So, it does some advertisement to know it supports this. We can go through this questions if anyone has it. So H2 sets up with HTTP2 and Prism, which if you look at is actually a Snowden joke. This chatter on the mailing list for why they came up with Prism was great. They're like, well, we can choose anything. We want to do that. Frames, fixed length header, binary protocol. And there's your types of frames. I guess that does matter because we do reference a few of them, but I'm not going to go into detail.
Yeah, the only thing that's worth immediately taking away from this slide technically is the fact that if you talk to any server on the internet that is currently implementing H2 right now and you change the order of these frames in accordance with the implementation of the spec, they don't all answer the same way. So yeah, H2 is everywhere, but it's still a relatively young protocol, and we're already starting to see deviations in implementation in the way that they handle the order of frames and what their immediate response is.
Yeah, some of them will send you an update or settings or a ping at different intervals and different orders, and yeah, you can fingerprint with that. Headers are compressed with Huffman encoding, which is actually really interesting as far as an encoding goes. You've got a static table of things you see regularly, your get methods, your user agents, all of that. Rather than sending user agent is Chrome, whatever, it's just like 12, because you got the table. And a dynamic table which builds up as you go through the connection. And this is fully stateful. You can't jump in the middle and make any sense of this. Fun pitfalls, and this is yours.
What? Connection reuse. I kind of don't even want to give all this away yet because the demo is going to be
All right.
a thing.
Do you want to skip ahead to the demo?
Yeah.
All right. So how about I jump to QUIC and we can always come back. All right, QUIC. Takes H2 stuff, adds in more stuff. Thing about QUIC is it combines your TLS and your transport protocol together. So where H2, does this and has a common layer underneath, with QUIC, the top bit looks the same from the app. However, QUIC with TLS integrated over UDP, but your streams go all the way down. You put an H2 frame, it goes into a QUIC frame. Your transport layer manages your app layer stuff. Yeah, much the same as H2. Skipping ahead because that is a cool demo, and we didn't have that last time.
Yeah.
We didn't have it 10 minutes ago. Yeah, that's... All right. QUIC has a couple of fun things. 0 round trip time. So it can actually start sending data with the first packet. No latency. It pads stuff out so you can't do Oracle attacks. Forward error correction. Disabled it just to annoy me. And multipath, but that's a whole other bundle of crazy. So as with H2, you've got a connection with some number of streams. And a packet... A packet contains frame packets, and those frame packets contain frames. Dragons. Bring up one of these again. You've got a UDP packet, which contains a public header and authenticated and encrypted data. And inside there, you've got a private header and some frame packets with frames. You can read that top bit without a key. You need a key for that. So QUIC is actually really annoying to try and make sense of, even with an encryption key. Advertisements, much the same way as with H2. So what can you do with these things? Well, H2, always encrypted, binary frame, blah, blah, blah. Really complex state, whole lot of side channels. QUIC, encrypted, really annoying to try and man in the middle. User space, you don't need any else help on that. Doesn't require a socket because it's UDP, which some of you will be able to work out the applications of that. And it's a real pain to fingerprint because it's variable length.
Yeah, I'm pretty sure we built the best QUIC fingerprinter in the world as a demo because it turns out everything that claims to fingerprint QUIC sucks at it.
Yeah,
it really just listens on 80 and 443 and goes, is that UDP? All right, it's probably QUIC. It tries to parse it.
It does. It's like, you laugh, but it really is that lame. You look at the code and it's like, really? Oh, it's not 80 or 443. There's no tools. It's faster and more reliable than TCP over UDP.
Just skip the...
Yeah, we're not doing any implementation stuff.
Okay.
All right, first demo because this is what you want to actually get to.
All right.
All right, I get to hold 2 microphones. Woo! So what we've got here is an H2 tunnel in, over QUIC, and H2 out. And why you should care about that? Well, we'll get to that.
Well, no, I'm waiting. Is it? Check. Check.
Oh, it's going, okay.
Why projector hate? Okay. Well, I don't know how I'm going to show you a demo if the projector doesn't like my laptop. That kind of... What'd you say? Press Alt and F5? It's a Linux laptop.
Yeah. Try a different dongle.
Nope. Nope. Yeah, I don't have that. That's not a thing. All right. Science. I did actually. I restarted X. No, because Google didn't make their libraries work with the real operating system, so blame Google. Seriously?
Oh, you have
Want to take a couple of questions while we wait?
Yeah, all right. Because that's my background.
Why?
Because occasionally I take this box to clients and I like to not get screamed out.
Fair enough.
All right. So I'm gonna give you a terminal to look at as soon as I figure out how to computer. All right. Never mind the numbers on the top. So you guys remember the diagram that you saw earlier, where it was a H1 to QUIC diagram on one side, and then a QUIC to H1 diagram on the other. So the way I've implemented that is as 2 standalone binaries. So there's a binary with a Go web server, which is a transparent, complete one-to-one HTTP proxy, so it doesn't handle all the HTTP verbs and all that stuff. That is implementable normally under a Go context, but again, Google writes shitty code, so if you try to do that idiomatically, it'll laugh at you and say the connect header makes no sense. So instead, we got 2 binaries. So what I'm about to do when I set the microphone down so I can type is I will initiate one binary, which, hang on. I'll initiate one binary, which will start the H1 server that we'll actually talk to, and I'll give it a dial-back address. The dial-back address is going to be localhost port and the secondary server. The secondary server is going to have a QUIC server, and then an H1 dial back, which is going to be the endpoint. In this case, what I'm going to do is set that endpoint to dial back to Metasploit. So I have a VM, we're going to load a VM, and then we're going to psexec, and instead of the psexec payload calling back to a native Metasploit listener, it's going to be calling back to an H1 tube that speaks QUIC in the middle. And with Wireshark running, I will show you what it looks like, which is basically fuck all. Set stuff up. All right, so first, Let's go to H1 to QUIC. H1 12700. Oh,
Yeah, you need to drop 0.
1 on word.
So this is the entry to the tunnel.
So now we have the entry server running, so now we're going to start the other one. Notice how this binary has more options. That's because you have to use SSL when you use QUIC. It's not optional. On H2, it's technically not optional as well, but they have an H2 variant called H2C, which doesn't require SSL.
Yeah, because QUIC mixes in your TLS, well, you're in crypto with your transport layer. You can't set up transport without crypto.
All right, so now we have our Metasploit listener, and I'm just doing this so that we can see where the listener is. And now, as soon as we start the VM, and as soon as I start the second server, then I'll do the VM callback, and everything will make sense.
You reckon this was... Oh.
I'm still typing.
Well, I'll just hold it.
Okay.
I'll be your mic stick. Because I have to eat this one.
What's my dial back port again? Oh, yeah.
Is it 88 or 88 you want?
80, 80. And then listener port. Oops. 1, 2, 6, 8, 4.1. I can't. Oh, no. No, this is easier.
This is how you be credible. You do it live. We could have done this in the video, but then the video wouldn't play, and yeah. Well, no, we did, but the next demo will be far, far more interesting and more nefarious.
Wait.
But when you see the packet capture for this, you'll understand.
And this is going back to 80, 80. Okay, I think that works. And then, where's my front end tube? My front end tube is 8888. Hang on. Sorry. Gotta wrap my brain around my own demo. Okay, yeah, I did that wrong. That's supposed to be.
Yeah, so we set the port wrong. We're just fixing that.
Oh. 104.1 on 88. And then this is funneling back to 8081. This listener needs to. I'm still typing. I need a hand.
I think next time we should mirror your screen.
Well, we didn't plan on this demo, remember?
Oh,
That's
yeah.
what happened. We didn't plan on this demo at all. Sorry.
That's fine.
File back to 88.
And this code's all available for you to play with yourself, so pay attention to what we're doing.
All right. Now I got to go to my VM.
All right, so we've opened up the tunnel. It'll take what goes in and send it out.
If I can remember where the heck I put my VM.
You're not an enterprise. How do you lose a VM?
Lose VMs all the time.
VM's all the way down?
Demo.
Demo VM. Probably a good start. Good old Microsoft browser test VMs. Really handy. All right, one VM.
Bum, 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 bum. All right, so there's our password. And just to make sure we know what the IP is. All right, so there's our IP, 829.
So we're PS execing through the binary.
Oh, damn it. God damn it. There's HTTP.
Interpreter, reverse HTTP.
Set our host.
Too many dots.
What was my IP again? 129. Alright. Set user. User. Set lhost. 4.1. Set port. I did everything right. So now I'm going to start Wireshark. And go away. We're going to go down to localhost. And that's going to show us a bunch of stuff. And now, if I didn't screw anything up, what'd I do? I did something wrong. Oh.
Listener was wrong.
Where? No, that's right.
No, it's not.
It's on 8888.
Yeah.
That's what's not supposed to be on. Goes back to here.
What'd you do?
I don't know.
Anyone else seen what we did wrong? No.
Oh, sorry. I know what I did. I'm stupid. There we go.
Oh yeah, that.
Alright. Still did something wrong. But, okay. There's our request. Our request went back to... Oh.
So we should have sacrificed that person to the demo gods.
It's cool. We'll figure it out.
Yeah, we'll figure it out.
Okay, I know what I did.
What'd you do?
I sent the listener to the wrong port.
Yep. Oh yeah.
Alright.
Take 3.
Something, whatever.
Right, so let's look at this. You got 443 in, 8081 out.
Oh, computers. It's calling back to the right place.
It's on 0, not 127. Should still bind though.
It's supposed to be on 0. Why is my mouse not
Wait,
working?
445. Go back. Read up top.
Oh, did I enter the wrong number?
Yeah, go back.
Go back to where?
Metasploit.
That's normal. That's normal. That's the thing.
Okay. Oh, that was the other one. Yep. That's Pearce exec.
All right. I don't know what I did wrong. Click it.
Do you want to get that going, and I'll continue through the slides?
I don't know what I did wrong.
Ah, right. Well, that was unfortunate. It worked perfectly the other day, but, you know, we'll have it going with a little less downtime. Okay, this one's working. Right, anyway. This was... That was what you're supposed to see. We had some trouble with the listeners there. We'll get that working by the end. Right. Let's talk through these fun things. Because of the way QUIC is structured, you can do some quite fun attacks with it. First one is, because it's most stuff right now just looks for the port, if you change your port, a lot of things will just naively accept it, especially in UDP space. Because it's complex, you have all sorts of side channels and scrambling. There's some protocol stego and those side channels, a bit like DNS text fields. We're pretty sure there are some polyglots. We haven't found any particularly interesting other than academic, but did you figure it out? He figured it out. Stego polyglots and stego multiplex polyglots. We'll discuss those a bit later, but that stuff is crazy mode. Fragmentation agility, you're jumping around all over the place, all these connections and streams and stuff. So, as earlier, you start with that, you multiplex it down. Or if you have multipath and you break it up across paths or connections, and then if you mux them together and you do the same things, you get this set up. You can already do this today, but if you get multipath and multiplex, you start chunking stuff all over the place. Good luck being an IDS dealing with that. Blah, blah, blah. Right. Forward error corrections, all sorts of fun. You can inject fake packets, because you know the FEC and they don't. And you can drop or corrupt packets to force them to recreate them. If you want to detect the client traffic for these, go for the upgrade, go for your SSL ALPN header, or your QUIC client traffic. As we said, UDP 80 and 443. Bidirectional patterns of communication. This stuff does not look like most UDP traffic. It's very chatty and back and forth. And there's no static identifier. You really have to parse this to make sense of it. And that's why we released that detector that Virus referred to earlier. Are you good? All right, he's still working on that. If you want to detect the service, it's actually a lot harder. H2 server, look, make an ALPN request to it saying you want to speak H2. Send us an upgrade header, see if it upgrades. QUIC server traffic, again, UDP 80 and 443, or simply try and connect to it, which is actually really messy because it expects the right crypto to come in. Blocking it, H2, actually easy. If it's over TCP, you throw in a proxy, you don't support it outbound, you rewrite it. If it's on a non-standard port, it gets a little messier. If it's QUIC, right now that you block on an 80 and 443, that'll block it most of the time. It won't block anyone using something like we do that sends that across a non-standard port. With Chrome, there's actually a policy setting that no one sets. Google says right now this goes over 93% of networks. So People aren't setting that. And you can fingerprint detect and parse it, but in the end, not so much. You bring these up in Wireshark. Wireshark's dissector for H2 is actually pretty good. Chrome with its net internal is also pretty good. It tells you the protocol, it tells you the stream ID, the remote address, and all that. If you're doing it with H2 log parser, it makes it into a somewhat more friendly view. H2I enables you to send and request arbitrary frames. Well, not quite arbitrary frames, arbitrary messages. NG-HTTP, like there's a lot of tools for H2 out there, just not many in terms of security tools. MIT and Proxy actually has support for this recently. That's the thing I'd encourage you to play with. Curl. Curl already supports H2. You send a request with the HTTP2 flag, it'll pull it over H2. You actually see if your browser's using this today by if you open up your Chrome, you go to your net internals, pull up your HTTP2 and your alternate service mappings, and you'll get what I've got here, which is from one of my browsers, where you have a whole lot of them. It shows you where they're using them, what the expiry is, probably more than you expect. Wireshark supports QUIC. It's not very good if it's on non-standard ports. You can also pull it up through T-Shark, largely by looking for your ALPN stuff, is how you can pick your HTTP2. For your QUIC, you have to force it to parse it and then pass through, pull the flags and the tags. It works. It works?
Yeah, it works.
Do you, okay, let's see if this works.
All right. So it turns out I don't know how to Metasploit, but after enough time, I figure it out. Okay. All right. So we got a shell. Yay. All right. So now if we look at Wireshark, and I move the window over so that you guys can see Wireshark. Hello. All right, so it's a PS exec, so you would expect to see a reverse HTTP handle, but instead all you see is a bunch of this UDP crap, and nothing has any idea what it is, and it's all on random ports. And if I manually tell this to decode as QUIC, not. All it sees is a bunch of encrypted garbage, and even if you look at the details of the packet, it pretty much has like 1/10 of the metadata of what it normally does when you're browsing. And yeah, lol IDS. There you go, demo 1. You want to go over multiplexing before I do the next? Okay, so the next demo I'm just going to do because my laptop's hooked up and we're running out of time.
So I can talk through it while you're
Yeah.
So remember earlier I showed you the multiplexing with all the different bits of different files and different orders. So what we're doing here is we're pulling in, we've got an H2 connection, which has a large number of streams within it with identifiers. And we've set up a program that opens up one connection, opens up a stream, grabs a random byte from the file, opens up a new stream, grabs a random remaining byte, basically grabs the entire file, or does your web browsing by randomly grabbing bytes via range requests inside that tunnel. So it's really noisy, but it's one connection that is really jumbling up the file. I don't know if this is a DDoS technique. I don't recommend, well, I don't know, find out. But basically, when this happens and we pull a lot of random parts of the file, it's incredibly difficult to reassemble it because you need to be scripting, and if we pull multiple bits more than once, it'll make a lot more sense when you see it. But if you've got, say, a file that is called 1,000 bytes long, we'll be pulling 100 random bytes at a time from that through the connection, multiplexing.
Okay, so this is actually a lot cooler than it's going to look, and I'll flash you through the source code real quick. But basically, so what this is going to What you're about to look at is an H2 request, where the H2 request is only requesting a head first of the content, and the head will return a content length. And then, for every byte of the content length, we're going to choose a byte at random and request it over H2 under an independent frame. So if you were to look at this in Wireshark, you would just get an entire frame center of return from HTTP and then a single byte of data with no context. But magically, it would look okay in a web browser.
Think of this as traffic obfuscation.
Because of SSL, there we go. So that is yahoo.com, 1 byte at a time, using as many connection IDs as it possibly can in order until my box runs out of network sockets.
Actually, no, it's using one socket.
No, it's not using that. No.
Wait, you're opening connections?
Yes.
What? Do you hate the internet?
Yes.
Apparently. It's slow. Think of this as a little analogous to, byte-wise SQLi. But good luck figuring out what you're doing here. Noisy, inefficient, a nightmare to reassemble whether encrypted or not.
All right, you go back to slides?
Slides are basically done. And we can do this with any arbitrary server that supports this. You can actually do this over H1 as well, but over H2 it's a lot gnarlier because of how the complexity of the protocol works. Have a laptop.
All right.
Yeah, so...
We're way out of time.
Yeah, we're way out of time. So, short of this, I'm just going to read off the slides as I go, rather than setting them up. Tools aren't keeping up with tech, and if the tools aren't keeping up, we need to. You need to be aware of these things, looking for these things, understanding strangeness when you see it. Even if your tools do it, playtime's over, because, if you come across this stuff in a packet capture, what are you going to do? So, tech's moving faster and faster. Vendors are driving it. Not security companies, not standards bodies. User space network stacks are coming, already here. When malware's putting this stuff in, things are going to get really messy. You could think polymorphic binaries are bad. Wait about polymorphic protocols. There'll be context-heavy, encrypted, and really heavily multiplex communications, more so than we've seen before. Yeah, right. Let's just shift to questions then. Cool.
Yeah, I'm pretty sure we're out of time, so I will stand there and answer questions.
Yeah.
Bye.